Dear students, myself Dr. Mallikarjun S. Biradar, Assistant Professor in Mathematics, Government First Grade College, Basuvakalyan. In the 26th session of Graph Theory 2, we are going to discuss geometric dual of a planar graph. You know already what is planar graph, but how to find the geometrical dual of a planar graph and what are the applications of this geometrical dual, that we will see in detail. So now first we will see how to construct a geometrical dual. So for that what we will do, first we consider a planar graph. You know already what is planar graph. A graph is said to be planar if it is possible to draw on the plane without the intersection of its edges. Once if you draw that planar graph on the plane without the intersection of edges, it is called embedded on the plane. So once if it is embedded on the plane, then that graph is called a plane graph of the graph G, of the planar graph G. So here we are considering a plane graph of the planar graph G. Okay, here is an example you can see. So we have considered one plane graph of the planar graph G. Okay, so once if you consider a plane graph of the planar graph, what you have to do to construct the geometrical dual, first you have to identify how many regions are there in the plane graph. For example, in this graph, how many regions are there? One is the interior region bounded by these three edges E1, E2, E3. Okay. Another one is outside, that is the exterior region, or you can say unbounded region. Okay. So that is the exterior region. So there are two regions. So now what we will do, in those two regions, we place a vertex. For example, this is the interior region, we place one vertex inside. Here you can see we have placed one vertex interior to the interior region. Okay, and we place one vertex to the exterior region. So here you can see this is the point representing the exterior region. So since there are two regions, or you can say faces, one is the internal face, another one is the external face. In each faces we have located those, or we have put one vertex inside those two faces. Okay, or you can say the number of vertices are equal to as that of the faces. So there are two faces, one is internal, another one is external. So we have considered two vertices here. Okay, now for a given plane graph G, its a geometric dual G star is constructed as follows. Okay, so what is the procedure? Place a vertex in each region or in the face of G, including the exterior region. Okay, and if two regions have an edge E in common, so for example E1, this is an edge which is common between the interior face as well as the exterior face. Similarly, this edge E2 is common between the interior face as well as exterior face, and also the edge E3 is common to the interior face as well as the exterior face. So these three edges are common to both interior as well as exterior faces. Okay, so what you have to do if this is the case, if two regions have an edge E in common, join the corresponding vertices by an edge E star crossing only the edge E. So in this example we will clarify. So here we have put one vertex interior to the interior face and one for the exterior face. As I said, these three edges are common between the interior as well as exterior faces. What you have to do, you have to join one edge to the interior face, exterior face, or the points corresponding to interior face and exterior face for the edge E1 as E1 star. So you can see here, this is the interior face representing interior face, this is the vertex representing exterior face. So this edge, crossing this edge, what we did, we have joined these two vertices. Similarly, the edge E2 is common between these two faces. So again you have to join these two vertices. Similarly, this edge E3 is common between the two faces. Again we join these two vertices crossing that edge. Okay, so crossing that edge is nothing but it is easy to follow the rule in the procedure what we have explained here. Okay, so therefore, so these three edges are joined to the corresponding vertices of the faces. Okay, so this is the procedure. Then in addition, one loop is added to a vertex of G star for each bridge of G which belongs to the boundary of that region. See, for example, in the graph G, E4 is a bridge. E4 is a bridge. So what you have to do, so this E4 lies to the boundary of the exterior region. Okay, so for this reason, what you have to do, for this edge, what you have to do, you have to put a loop at the exterior face or the vertex corresponding to the exterior face. If there is another bridge like this, you have to join one more loop here. Okay, but right now only one bridge is there which belongs to the exterior region, obviously. So therefore the vertex corresponding to the exterior region is joined with a loop, okay, for this bridge. Okay, so this is the simple procedure how to construct a geometrical dual of the graph. Then we will get this graph. See, these are the vertices corresponding to the faces, and these three edges corresponding to the edges which are common between those two boundaries or regions, and this is a loop corresponding to the bridge of the graph G. So this is how we got a geometrical dual G star of the graph G. I think this concept is clear or understood properly. Okay. Now after this, we will define what is underlying graph. Underlying graph. So after constructing the dual or geometric dual, we used to say dual also in simple way. We used to say dual. So geometric dual or dual one and the same. So after constructing the geometric dual, what we have to do? See, between these two vertices there are three edges. So there are three edges joined to these two vertices. So such edges are called multiple edges. So if two vertices are joined by two or more edges, such edges are called multiple edges. So to construct an underlying graph, or what is underlying graph, we will see here. If each set of multiple edges of G star is replaced by a single edge, here between these two vertices there are three multiple edges. Instead of three multiple edges, consider those two vertices and put only single edge. So this edge for these three multiple edges. Okay. And what you have to do? If each set of multiple edges of G star is replaced by a single edge and all loops are deleted. So this is the loop. You have to delete all loops. So it implies you are not considering any loop. So after that, whatever the graph you are getting, the resulting graph H is called the underlying graph of G star. What is G star here? G star is the dual of G of a planar graph or plane graph G. After finding the G star or geometric dual, what you have to do? Instead of multiple edges, you have to consider only single edge and delete or you have to neglect the loops. Okay. So therefore, the resulting graph is called underlying graph. So here G star is the geometric dual of the graph G and H is the underlying graph of the G star. I hope you have followed how to construct the geometric dual as well as the underlying graph. Now we will see some more examples here. Give an example of a geometric dual. One example you have to give. It implies you have to consider your own planar graph. It is to be plane graph because you need to identify the regions, faces, interior faces as well as one exterior face. So to identify the planar graph must be embedded in the plane. So you have to consider only the plane graph. Okay. So you have to take one plane graph and identify the regions. Then for each region or for each face, one vertex is considered. Okay. So what we did, we have considered one graph here. So this is the graph. This is the graph with the bold lines. Okay. Right. So what we did, so there are how many interior faces? One, bounded by one triangle type. This is another face, interior face, bounded by another triangle type. So there are two interior faces and one is exterior face. Another one outside unbounded region is called exterior face. And there is one bridge. Okay, as we said, so first you have to consider, or you have to put one vertex in each region. So therefore we put one vertex interior to first region. Similarly, the second vertex interior to the second region, and one vertex outside for the exterior region. Okay, so three vertices we have considered. So three vertices we have considered here, 1, 2, 3. Okay, now as I said, between two regions, which are the common edges that you have to identify. So these are the edges. Okay, first we think of the interior faces. So this is an edge common between these two faces. So that's why you have to join these two vertices crossing each line which are common to those two faces. So this is the only one line common to these two faces. That's why we have joined by dashed line. Okay, now for this reason, so these are the two edges which are common to the interior face as well as the exterior face. That's why we have joined this vertex with the vertex representing the exterior region. Similarly, this vertex crossing this edge, we have joined one more edge to this vertex. Okay, now these are the two edges common to the exterior region. So that's why this vertex is joined with the other vertex by crossing this bridge. Similarly, one more edge is joined crossing this edge between these two vertices. Okay, now as I said, for the bridge you have to consider a loop for the exterior region, because bridge is lying on the boundary of the exterior region. So therefore one loop is considered for one bridge. Okay, so this is how the three vertices, the inside these three vertices with the dashed lines is the geometric dual of the given graph G. Okay, then we got geometric dual. Now how to find its underlying graph? As I said, instead of multiple edges, you have to consider only one single edge. So therefore you have to identify which are the multiple edges. See, between these two vertices, one edge, two edges. So these are the multiple edges. So instead of that, you have to consider only one edge. Okay, now between these two, again this is one edge and this is another edge. So there are multiple edges between these two faces. Okay, so therefore you have to join by only one edge, right? So like this we got the underlying graph. Because and one more thing you may ask, why we have joined this one? Yes, of course, because there are three reasons, two interior and one. So because two interior are joined by one common edge, so that's why one edge is joined between those two. So therefore this is how we got the underlying graph of the geometric dual. Now some observations. If we observe, observation is very important. Once if you consider any concept and if you analyze that, you must get some ideas in your mind. What are the observations? If G has a bridge, then G star has a loop, definitely. If G has a loop, then G star has a bridge, definitely. If G has a loop and G star has a bridge. If two regions of G have at least two edges in common, then G star has multiple edges. It's very important. If two regions of G have at least two edges in common, then G star has multiple edges. If G has multiple edges, then two regions of G star have at least two edges in common. Yes, this is another observation. Okay, so now the number of edges constituting the boundary of a region in G, yes, you can guess, I think, is equal to the degree of the corresponding vertex in G star and vice versa. Very important. The number of edges constituting the boundary of a region in G is equal to the degree of the corresponding vertex in G star. Definitely. How many edges are common between those two? Okay. And vice versa. So this is how, these are some observations. Okay, two more observations if you consider. The graph G star is also embedded in the plane. Yes, it is possible to find the planar type graph, or you can say you can draw without the intersection of edges. So it is possible to draw the graph G star on the plane without the intersection of edges, or you can say G star is also embedded in the plane, and hence it is planar. So therefore, if G is planar, G star is also planar. So this is the observation. Okay. Considering the process of constructing a dual G star of G, it is clear that G is a dual of G star. See, once if the plane graph is given, you can find its geometric dual G star. If G star geometric dual is given, if you can find the geometric dual of G star, so what you will get? You will get the graph G. So that's why there is one result, the G star whole star. You can say the geometric dual of the geometric dual is the graph G. Okay, so these are few observations we have discussed. Now we will see the second example. Draw the geometric dual of the graph G shown below. So one graph is given. So first think of this. This is the graph. This is the graph. Okay. So now how many regions are there? 1, 2, 3. Okay. And this is one region. Of course, multiple edges are joined. So these two edges are lying in the boundary of the exterior region, and one loop is there. Okay. So therefore, if you consider, so previously we have considered if G contains a loop, what we have to do? If G has a loop, then G star has a bridge. So that you have to remember. If you consider any loop in G, for that loop you have to consider a bridge in G star. Okay. So with this observation, we can try to find the geometric dual of the graph G. The same procedure you have to follow. This is the first region bounded by these two. This is the second region, like a triangle type. Third region is also triangle type. Fourth region is also triangle. But there is one edge which is lying to this region. Don't say this is lying on the boundary of the exterior region. This is an edge, or you can say it is a bridge type. It is lying on the region, fifth region, on the face, fifth face. Okay. And the sixth one is a loop. Okay. Fourth one is the exterior face. So instead of faces, you have to consider the vertices. Follow the same procedure which we have explained or which we have discussed right now. You will get the geometrical dual or geometric dual of the graph G in this way. So the points along with the dashed lines represent the geometric dual of the graph. Okay. So in figure 2, the graph G and its geometric dual are shown. So very easily you can verify. Now if you consider the third example, show by construction that the dual of the two graphs G1 and G2, two different graphs are given here. Okay. So if you find the dual of these two graphs separately, dual graph of G1, that is G1 star, G2 star, if you find out, show that they are isomorphic. So those two graphs, that is G1 star and G2 star, are isomorphic. You know what you mean by isomorphism of two graphs. Okay. So that already we have discussed in the 5th semester. Okay. So now we try to find out the geometric dual of those two graphs. First try to find out the geometric dual of the first graph. Okay. As I said, first you have to identify the regions. So this is the one interior region. Okay, like square type. This is the one interior region, triangle type. This is the third region, triangle type, and one region is exterior region. Okay, and follow the same procedure after considering one vertex for each face. Now you have to join two vertices if there are edges common between those two faces. So like this. So this is an edge common between exterior face as well as interior face. Like that, if you follow the procedure, we will find out the geometric dual of the first graph. Similarly, you have to identify the faces of the second graph and insert one vertex in each face and one vertex for the exterior face. Follow the same procedure, you will get geometric dual of the second graph. Now separately I have taken the geometric dual of the first graph and the geometric dual of the second graph redrawn, because the location of the vertices and straightness of the edges in graph theory is immaterial. It doesn't mean that you have to join two vertices only in a straight way. Even you can join two vertices by curved line also. So therefore, if I redraw those two diagrams, what we will get? So these are the two graphs of the geometric dual of G1 as well as G2. If you observe these two, so what you will get properly? Once again, let me see. Those two are same graphs. Number of vertices are also same, number of edges are also same, and even one-to-one correspondence. So therefore, you can say these two graphs are isomorphic to each other. Okay. So what we have discussed in this session. So what is the geometrical dual of a plane graph, and what is the underlying graph, and some observations based on the geometric dual as well as the underlying graph. And we took some examples to understand or to clarify what is geometrical dual or how to construct the geometrical dual as well as the underlying graph of the plane graph J. I hope you have understood these concepts. These are the reference books. Many times I have told you. So with this we conclude today's session. Thank you.